All right. So, oh wait, what's going on here? Wait, this is like frozen. What? Bro. Okay, I guess that's working now. That was weird. Alright, so this is what we got working on yesterday. And I think if we, so I'm going to do it in on shape. However, and I'm actually going to 3D print the case. For some reason, Onshape is like really slow in Linux Firefox, so I don't know. But so this is what I have so far. So the idea was like to have kind of like a T-slot thing, but it just has like M3 nuts in there, and you just screw it onto the thing. I was looking at the specification, and this 6.8 millimeters actually seems like pretty in spec. You're supposed to use M3x6, but if we end up feeling like that's a problem, I can always adjust this sketch and just add another pocket here, because the print plan for this whole thing is I'm gonna print it this side up. So this face will be pointed up because then it can just print nicely. Now, there is another mechanism. So, more broadly, it's probably worth justifying, like, why do this? One, it's always kind of bothered me that I have all these PCBs and these synth modules, but I have really nothing to show for it because there's no cool demo. I can't show people, oh, look at the modular synthesizer and it working. It's just, here are these PCBs, but nobody knows what they do. Plus, I feel like I've learned a ton of CAD. I've also learned machining. I've also learned a little bit more about electronics, or at least the process of manufacturing PCBs. And so I was thinking it's probably a good time to revisit the project and just maybe kick it up a notch. So, but then there's another thread going on, which is the interest in code-based design tools. So we've looked at Zoo in the past, and we've looked at Onshape's scripting capabilities. We've also looked at FreeCAD's scripting capabilities and all of those, and the whole idea that design can be written in a programming language. And I have discovered a new tool that we are going to use to at least do the schematic capture of our PCBs. And that tool is called Atopile. Okay? So Atopile I found from this cool guy on YouTube called Atomic, and I've seen his videos in the past. He does really cool videos. But he showed this video of vibe coding with Atopile. Now, I'm not going to vibe code it just because, and I was thinking about this more broadly recently, actually. It's like, when should you vibe code something? Now, I think you can vibe code whenever you want, but I feel like probably the process of vibe coding is more fun if you actually understand what's going on, because then you can more easily spot what's wrong, and you're not just like helplessly at the mercy of this LLM that's like frequently going to make errors that you have no idea how to diagnose. So with that said, we're just going to write it manually, and I have all of these ideas for PCBs that I want to make, but I think the first PCB I want to make is not going to be an actual Eurorack module. And the reason for that is that what I'm planning to do is also to upgrade the fabrication process. So I'm planning to use stencils, and I'm planning to use surface mount parts. Um, so there's sort of like kind of two threads going on here. So um, so let's hop into this. The first thing that we're gonna actually build and route, and I'm actually planning to order a PCB today, just so that I can like, because my whole fear, the reason why I made PCBs in general was, oh, and I'm not gonna be able to see my chat because okay, so let's just pull that up just so that we have that going. Where am I at? Wait a minute. Am I even live in the right place? Oh yeah, I am. Okay. All right. So we can. So unfortunately, I have no ability to view the chat here, which is kind of annoying. All right. So yes. So the first thing that we're gonna build is the Ben Eater clock module. Now I've already actually built the simple. So here's the schematic. So I already built. Is it this one? He has a he has a better thing on his video. Hold on. Bro, why does Firefox have so much insane shit in it? It's actually insane. Why is Firefox getting an ad from someone to recommend me to go to a microbrewery? It's like Firefox has no sense of what the hell they are talking about ever. Okay, so let's just there's one picture here that I want to go through because I always like to walk through.
So what's going to happen is we're going to have
this. I want to walk through the schematic. There we go. Okay, so this is the 555 timer. So we have a V in, we have a ground. Okay, then we have this voltage divider, and the idea here is that we're gonna want to. In the end, he makes it a potentiometer, and we're gonna need to think about how exactly that is gonna get done, because the thing about these panels is that you typically will have some standoffs here. And actually, can we look at like power supply at 4 HP Euro rack? Let's just look up that. I think we'll find like a Behringer. Yeah, but the thing about the Behringer one is it probably doesn't even show its construction. The image I remember that it shows is like kind of a joke. Oh no, but you know what they do actually? Hold on, I don't like this. This isn't good either. There's this guy actually. Bro, my computer is actually pretty slow. Kind of upset about that. But me built. This guy is really cool. So I kind of just, I mean, it doesn't really matter which one we look at. What we're looking for though is the assembly. Okay, so he does the SMT stuff. He's got his panel. I mean, that panel is dope. With the text and everything, that's really cool. Okay, he's doing some cleanup, I guess. Alright, this is the part though that let's see. Cleaning it up. Okay, so I think the way that they typically do it is they don't have explicit standoffs, but I wish I could, let's get a look at this thing. So, basically, each one of these things, they use a standard height, and I don't know what that height is, but then you put the front panel on that, and then you put a nut on top of it. And we'll need to figure out what that package is, because I don't know what that is. This dude is so talented, man. It's interesting that he designed it with slots here, right? Because in case it like doesn't fit quite right. Wait, actually, what did he just do? All right, so we also need to figure out what that connector is. Okay, but let's just get something down, I think, and we'll go from there. So there's gonna be a lot of back and forth. Okay, but now let's just think about the operation of this. Let's say that S is high, so S got set. All right, so that means that Q is high, right? Because if we go to here and then we go to logic families, RTL, no, combinational logic, probably sequential, yeah, it's SR flip-flop, here you go. All right, so wait, these are both asserted high. So if we assert this, what happens is these are two NAND gates hooked up together, right, in a loop. Now if I set this, then this is going to go high. Because, okay, right now, this is high and high. And the NAND truth table is not and. So this is going to go low. Okay, so this is low. So then only in the high case is it low. Okay, right. It's Q bar. So then we go back to the picture. This is high. This is going to stay high until we hit this. Okay, so now, but when is this going to get hit? This is astable, so it's going to get hit eventually, right? So when would this be asserted high? When this would be asserted high when this voltage is less than 1.67. Because if we duplicate this and we go to circuits, circuits, op amps. Oh yeah, this is what we want. So if the plus is greater than the minus with just these basic no feedback inputs, then it's going to go to the high rail. So let's say that this is low. So this has been drained or something. But that means that this is low. So this is filling up. So this is filling up right now. We've asserted this, but it's going to start to fill up. So the minus voltage when the charge builds up on this capacitor is going to go up. Now when it hits that point, this is going to go low, right? But when that goes low... Here, let's watch him explain it, because he explains it really well. Let's see if I have desktop audio. Oops.
Inside the timer itself. And then the green stuff that I've drawn out.
Oh, you know why I don't have sound, I think? Yeah.
Out here is the rest of the circuit. So
Still no sound.
we can kind of go through and look at what we've got. So this 1K, this is a 1K resistor going from 5 volts to pin 7. And then between pin 7 and 6, that's this 100K resistor here. And then you can see pin 6 and 2 are connected. That's this little green wire going around here. And then between pin 2 and ground, we have this 1 microfarad capacitor. And then over here we have our LED, and this is our, I think it was a 220 ohm resistor over here. So this is our circuit. And to understand how it works, we can kind of look at what's going on inside the 555 timer. So I just start by looking at this path through here. You can see we've got our plus 5 volts up here, and then of course our ground down here is 0 volts. And then there's these 3 resistors, and I think each of these resistors inside here is 5K. So 5K, 5K, 5K. I think it's a complete coincidence that it's a 555 timer, but anyway. But what these do is these set up a voltage divider. And so at this point here, you've got 1/3 of the voltage between 0 and 5 volts. So that's 1 and 2/3 volts, so 1.67 volts we'll call it. And then at this point here, we've got 2/3 of our 5 volt supply. So this is 2/3 is 3.33 volts. And so you've got this voltage divider. So you got 5 volts, you go through this resistor, you're down to 3.3, you go to this other resistor, you're down to 1.6667, whatever. You go through this other resistor, and you're down here at ground at 0. And what that does, that sets up these inputs for these comparators. And the way the comparators work is there's a positive input and a negative input. And if the positive input is above the negative input, then the comparator switches on, and the output is 5 volts. And if the positive input is below the negative input, then the comparator switches off, and the output here is 0 volts. So let's think about what happens when we turn this thing on. Get this out of the way here for a second. So what happens is, let's assume that these inputs over here, this is all 0 volts. So we've just turned this on, stuff is 0 volts. So we've got 0 volts coming in here. That is below 1.6 volts. And so this comparator turns on. And so that triggers the set pin of our SR latch. This comparator turns on. And so that triggers the set pin of our... And so this comparator turns on. That is below 1.0 volts. Inputs over here, this is all 0 volts. So we've just turned this on, stuff is 0 volts. So we've got 0 volts coming in here. That is below 1.6 volts. And so this comparator turns on.
Yeah.
And so that triggers the set pin of our SR latch. And if you don't know what an SR latch is, I've got a video on that. But basically it's got a set and a reset. And when the set goes high, then the output comes on. And when the reset goes high, then the output turns off. And then of course, if they go low, then it remembers its last state. And there's both the output here, and then there's the inverted output here, which is always the opposite of our output. So we have 0 volts here, we got 0 volts here. This comparator will be on because 0 is below 1.6. And this comparator will be off because 0 is not above 3.3. So this one's off, this one's on. And so the latch is going to be set, which means our output will be on. So the LED will be on. So we're going to start on. So we'll do a little graph here. And if our output is on, then our not output, our inverted Q here is going to be off, and so this transistor will be off, and so nothing's going to go happen here. We can kind of ignore this whole discharge thing here for now. So what's going to happen is we're going to have current flowing through this 1K resistor, through the 100K resistor, and into this capacitor down here, this 1 microfarad capacitor. And that capacitor is going to start to charge. And so if you look at the charge on the capacitor, which is also the voltage here going into pin 2, it's going to start, move this, so you can see here, it's going to start here at 0 volts, and it's going to start to climb. And it's going to keep climbing and climbing and climbing as this capacitor charges. And so what's happening is the voltage here is increasing. And at some point, it's going to increase above 1.6 volts. And if it's above 1.6 volts, this comparator will turn off because 1.6 is no longer above whatever this voltage is. So this comparator turns off, and that's fine, right? Because the latch is going to latch its output. So we're not asserting the set pin anymore, this set signal. But if we haven't reset it yet, we're still going to have a high output here. But eventually, this voltage is going to reach 3.3 volts. And it's going to maybe go a little bit above 3.3 volts. And at that point, that voltage is going to be above 3.3 volts, and this comparator will turn on because the positive input here is above the 3.3 volt negative input. So this will turn on, and this will reset the latch. I guess I didn't give myself enough room here, so ignore that. So this is our output. Our output is going to get reset when this hits 3.3 volts. So this is like 3.3 volts on our capacitor here. Maybe this down here is 1.6 volts, and then we'll say this is 0. So we started at 0. We went through 1.6 volts. Nothing happened. We turned off the set pin, but we stayed latched. And then we get up to 3.3 volts, and at that point, our output turns off. But the other thing that happens is our not output, our inverted output, this turns on. And that's going to cause current to flow from here through into the base of this transistor, and that'll turn on this discharge transistor. And so then what happens is, current can now flow through the 1K resistor, through this discharge to ground. Okay, that's not very exciting. But what's more interesting is that current can also flow from the capacitor through the 100K resistor. So before we were charging the capacitor in this direction. Now we're discharging the capacitor. Current is flowing from the capacitor through the 100K resistor and through this discharge.
So when you modulate
the capacitor
that
is going to start to
100K,
discharge.
it's gonna
and it will discharge for a little while.
It's going to go
faster.
faster.
As soon as it starts discharging, it'll drop below that 3.3 volts, and so the reset will turn off. But again, this is latched, so nothing happens. But eventually, the capacitor's voltage will drop below 1.67 volts.
So I wonder, actually, there probably is a square wave generator. This is probably the A stable, right? So this is going high and low. So here, let's see, what is dis? This, I think, is just a pin, right? I don't know all these names. Let's see if we can do this. How do I pan? Can I pan? I don't know if I can pan. Okay, so VCC, this is at 10 volts. Reset. Oh, I think he draws in that pin later. I don't think it actually like matters. It's just like good to assert it high or low or something like that. Okay, so then this is the thing. And this is going to be the frequency control because right, so this is threshold. So this is trigger, this is threshold. This is kind of weird, actually. So what is this? This is output. Okay, so output is the square wave. That's kind of interesting. This is sort of a different setup than what we had. Maybe we can modify this. What is cuddle? CTL. This is probably... What is the actual pinout? Control. So in here, we only use 7, 6, 2, 1, and 8. 7, 6, 2, 1, 1, 8, 2, 7, and 6. And then out, and 3. So we're not, so these two are ignored right now. Okay, so let's just see if we can get, wait, hold on. Okay. So, so let me just draw this. Ground, trig, out, reset, VCC. I think this pen is out of ink. Yeah, hold on. I left my backpack inside. What is dis? Dis is discharge, right? So this is 2, 3, 4, 5, 6, 7, 8. So 6 is threshold, and 5 is control. So evidently we don't need those quite yet. And I forget how to use falstad, but let's just start from scratch. So add wire, passive components, active components. Digital chips, flip-flop, analog and high. Okay, here we go. Add to 555 timer. There we go. How do I move it? I think I have to get out of this mode or something. Can I move it? Okay, I can move it. So now we want to add a voltage. I actually kind of prefer the, or we can do, so add wire, inputs and outputs, add ground. Yeah, I think I prefer this. Okay, so now let's move this. So we have this, and then we want to ground. Great, so now it's flowing through here. Now what we want is a LED. Or rather, inputs and outputs. Audio input, interesting. Oh, outputs. Yeah, we could do LED. What about this? Yeah, I think that's what we want. Oops. I think that this just measures it to ground, right? How do I... Is it showing it? Oh, it shows it here. But can I add it in a view in new scope? There we go. Okay, now we want our 1K, so we want a resistor hooked up like this to pin 7. So there's our discharge. Okay. We also want our 100K. We want another resistor. And this is going to go to probably this, right? Now the trigger is also hooked up to this, right? And now this, we want a capacitor. And we want a ground. Now, this definitely seems wrong. So what's happening right now? This current is just flowing through here. So we need to make... Alright, so let's start to get this... sorted. 1 microfarad. Let's make this 5 volts like it's supposed to be. And I wonder if I can... Oh, but you can't show both of them. But I feel like I want documentation on this thing because I don't really understand what I'm doing wrong. So... Okay, so let's just tie the reset pin high. Oh yeah, because you have to click and drag. Okay. Oh, there we go. And then I want to know the charge on the capacitor. So see how the voltage on the capacitor is going up? It's gonna start dropping down when it gets to 3.3 volts. Or at least it should. Okay, so now it's going down. But it's discharging very slowly. But this is low now. I wonder why it's discharging so slowly. It seems a lot slower than... Oh, see how fast it is now? Alright, but let's keep this at 1U, which is slow. And then we're going to change this. If this was only 1K, okay, it's switching faster now. Here we go. So what we want to do is add a variable resistor. So passive component, potentiometer, okay, I'm down with that. Okay, so what we want here, so the total resistance, the lower the resistance here, so let's make it like a 10K. And then this is just going to be ignored. Then instead of this, oops, this is going to go to here, and this is going to go to here. Now, how do I change this? Oh, I can change it like this. So if I make it bigger, then this frequency gets lower. No, I think he does some computation to figure out how fast it's going to go. And this seems like whatever is internally in here is different, because with all of these same parameters, 5 volts, 1K, 100K, the frequency was like 1/10 of a hertz, or whatever, however you say it. So so I think I'm ready to build the Atopile circuit of this. I think the main thing is that let's just stick to surface mount resistors. We'll figure out once we have it all down, because I do kind of want to just do the layout. Yeah, because we basically need to choose what footprint of this button we want to use, because because we're going to want to change the frequency. I guess that also means that whatever 555 that we actually pick, we will need to look at the data sheet for it. But so let's we can keep that open, but I'd like to show this now. So and actually, so this is sort of what I have so far, and it's kind of random. Wow, they added all this windsurf and cursor stuff. I've never tried that. I kind of want to. But so let's look at these parts here. So I added this 555 timer part. We can see here, this is the LCSC number. So let's just go to lcsc.com and we'll search for this part. And we have this. So what's cool about this is, okay, you have to buy at least 10 of them, I guess. But they're like 4 cents a piece, which if you think about that, that's kind of crazy that this part is 4 cents. Now I actually want to look at, if we go to, okay, so here's the pinout, and I don't know how this was generated, to be honest. Like, did LCSC provide this, or did they parse the did they parse the data sheet? I just don't know how they did this. It was auto-generated, but how? Okay, and then here's the footprint. Okay, here's the KiCad symbol. So unfortunately, you know what? Maybe we should just do this. I mean, I know I'm jumping around a lot, but just to like get the juices flowing, let's do this. And we're just gonna make clock. So this is gonna be totally separate. The only thing here, and this is the kind of the reason why I was looking earlier. I think I do A, right? Like if I just look up 555. P 555. Alright, so this is probably what we want. D for, whoa. Okay, so that's definitely it under timers. So I always had a hard time parsing all this, but presumably if I search this, if I copy this and go back to our Atopile, let me write this down. LSOIC8 3.9 by 4.9, and then pitch. So actually that's interesting. So the pitch here is 1.27. So yeah, so this is like half pitch. Like if you think about it like a breadboard, for instance, it's twice that. But this does look like the exact same footprint, just with a sort of different name. So we can just enter this in here and use this. All right, that's great. I think I might have actually mouse and touchpad. Just reset the mouse defaults. Okay. How do I do this again? Okay. So VCC. So I forget in general how KiCad works, because I feel like there's a lot of random lore. Like, oops. Oh, G is for grab, but am I supposed to use this? I feel like I always get confused. Like, do people use this or not? But then, like, if I want to add like 5 volts, like, do we actually? Because I know that there's like a. Oh, isn't there a way to just add only power or something? Yeah. Okay, so then we do this. So we have 5 volts. Now, oh look, they have a bubble here to see that it's reset. So this is So this S is what? Let's go back to this. Oh, I think, you know what I think it is, actually? Yeah, this just, pin 4 just ties directly into an a NOT gate. Can we actually look up a 555 decapped? Or yeah, let's look up like a timer die. That's really cool, dude. Can we look at a little bit of the lore? Bro, these angel number people are crazy. Who actually designed it? The design was first marketed by Schematic and used BJTs. How did they... Acquired by Philips? I don't know enough about semiconductor manufacturing. Can you make BJTs? I guess, yeah. I guess there's... Yeah, I guess you can. Oh, here's this drawing. Nice. This is a good drawing. I don't... Why is this inverted, though? This is a nice drawing. I like this drawing. So wait, pin 5 was... Let's do the... Show pin numbers. I wish it would show both. It'd be nice if it showed both. So pin 5... Oh, but you can just assert that value. Okay, that makes sense, kind of. So for pin 5... Do we just leave it unhooked for the whole time, or does he do something additional?
Means we're not going to be, inadvertently resetting this if there's just some noise. So that's just something else we'll do. And then the last thing I want, inadvertently resetting this if there's just...
Actually, yeah, so can we watch that? The streaming experience has not been incredible with this computer. It is a little bit slow. Alright, so we don't need this, but we need the documentation though. And their documentation is not amazing, I would say, but they are like super responsive on Discord. So I'm like kind of into this, and it's like pretty open source. It's the only thing that I hate is that they had this freaking telemetry thing that just will not die.
That we're doing with this capacitor here. Now, ideally, what you'd want to do is you'd want to get this capacitor as close as possible to the chip and put it right across the power pins on the chip. And if you look in any electronics, every chip is going to have a capacitor or maybe multiple capacitors sitting right next to it to smooth out these current transitions. I'm not going to get too crazy with it. I think I didn't draw it on the diagram here, but what pin 4 is.
Yeah, I'm trying to resist my urge to make it perfect. Like, it's just not going to be.
Is it kind of gives you this other connection here to the reset of the latch. So it gives you kind of a direct connection in here to just reset this latch if you wanted to. And actually, I should draw it. It's inverted input. It's not hooked up exactly like this, but this is basically how it functions. Is if you bring pin 4 low, it'll just force this latch to reset. It overrides anything that's going on over here. So normally we wouldn't want to bring that low unless we wanted to reset this. And so what the datasheet recommends doing is to prevent it from accidentally, going low if there's some stray voltage or something. It recommends, if you're not using it, to just tie it to 5 volts. So if we just connect that to 5 volts, then this will always be high, which means we're not going to be, inadvertently resetting this if there's just some noise.
Yeah, but then that's going to be low. Isn't there going to be a conflict?
So that's just something else. It means we're not.
I don't understand that. I feel like there's going to be a conflict now. So now you're asserting that this is low, but when does the op amp just like overpower? I don't really understand. I don't know if that makes any sense, but like I feel like it kind of makes. Oh, bro, I hate that this thing. ChatGPT made a change where it defaults to this freaking 4.0, which I don't like. It used to not. It used to remember that I wanted the model that I want, but for some reason, I can't just save that I prefer a model. They're being stingy with the tokens, bro. See, like, why is it glazing me, bro? I don't need a freaking AI to glaze me. I'm switching over, bro. I'm switching over. Wait, where's my... It's great you're looking into the internals. Don't tell me that. You pull it low to force the flop back to 0, yeah. Wait, what? That's not right. Pin 4 is not tied to the S. Okay, you know what? I actually don't care. I don't care. So let's just keep watching. I just want to see if there's a pin 5
resetting this if there's just some noise. So that's just something else we'll do. And then the last thing I wanted to do is I want to be able to control the speed of this thing. So we have it blinking at this 3.8 times per second.
Here, so wait, where does that come in? Okay.
Of course, we can control the rate that the LED is flashing based on the values of these resistors and the capacitor, right? Because the rate is set by how quickly this capacitor charges and how quickly it discharges. And so how quickly it charges is going to be dependent on these two resistors and the capacitor. So the bigger these resistors are, the slower it's going to charge. And of course, the bigger the capacitor is, the longer it's going to take to charge. And then if these resistors are smaller, then it'll charge faster. If the capacitor is smaller, it will charge faster. And then for discharging, so the time when this is low, it's just discharging through the one resistor here. And so, again, if this is a bigger resistor, it'll take longer to discharge, and so this will be low for longer. If it's a smaller resistor, it'll be faster. And so by adjusting these components, we can kind of control the rate here. And so one thing you might notice is that I chose a 100K resistor here, and then a relatively smaller 1K resistor here, and this is only 1% of this. And that's because as we're charging through both, and when we're discharging, we're only discharging through this one. But I wanted this square wave to be fairly symmetrical. And so by this only being like a 1% difference in the charging from discharging, you end up with essentially the same time that it's off that it's on. It's sort of what's called the duty cycle. And if you look at the data sheet, they actually give you some formulas here for figuring out the time that it takes to charge or discharge. So charge time, discharge time, and they actually show a nice little graph. Looks very similar to the one that I just drew. But you can see, they give you the charge time is based on RA plus RB. I think they're calling this RA and this is RB times the capacitance, which is the C here. Whereas the discharge time is just based on RB, right? Because we're only discharging through that one resistor, so you don't see RA in there. And then the total period is RA plus 2RB, right? Because it's RA plus you're going through RB twice for the total period times our capacitance. And so we can figure out our total period just using this formula. So we can pull out a calculator here, and so just sort of order of operations here. Resistor B is 100,000
like the natural law
times 2,
and
then we can add in resistor A is 1,000 ohms. That's our 1K resistor, and we'll multiply that by our capacitor, which is it's a 1 microfarad capacitor. So I think that's 1 microfarad, and then we multiply that by this 0.693. And the reason you're multiplying by that is the resistance times the capacitance gives you the time constant. And that's using
let's skip ahead because I kind of just want to know about this capacitor
double check
thing.
all this for my probes. We can see the charge at 2/3 output at 5 here for 5 volt. It says typical is 3.3 volts, and we're getting a little bit more than that. But it says the minimum is 2.75 volts, so we should be getting at least a minimum of that, which is fine. That's enough for logic high level. So if we're feeding this into any kind of digital logic, we'll be okay with that. And then we should see 139 milliseconds here. So this is 50 milliseconds per division. So this is 100, 200, and so that's not quite. Not sure why. I'll double check this. Well, I figured out the mystery. So there it says microfarad microfarad MFD on them, and they all, or at least all the ones I measure 2 microfarads. So if we plug that into our formula, we had 1 microfarad there. So if we plug 2, we're basically multiplying by 2. So multiply that by 2, 278 milliseconds. And we're measuring 263 milliseconds period here, and that's much more in line. That's certainly within, we've got 5% tolerances on these resistors and stuff. So 263, 278, close enough. So very interesting. I always assumed these were 1 microfarad, but apparently not. I think the 1 MFD means 1 microfarad, but apparently 1 MFD plus 3.
Bro, he just does not let it go.
About power supply. We've power supply recommendations in the data sheet, and I want to talk a little bit about power supply. We've got this is just a cell phone charger. This is from Apple, which is actually a very good power supply if you get a genuine Apple one. But in any event, it looks like everything's working fine. Our LED is flashing. We've got our nice clock output here, so you could probably use this and it would work okay, probably. But there are a few things that the data sheet recommends doing to reduce noise. And so one thing it recommends doing is putting a capacitor on pin 5. We're not using pin 5. It's control voltage. It's for some other features of the 555 timer that we're not using. And it recommends putting a 0.01 microfarad capacitor from pin 5 to ground to reduce noise. So what is it talking about? Well, we see on the scope here, we see this nice transition from 0 volts to 5 volts. But if
that's smart, actually, because you can't tie it high or low. That'd be crazy. If we start this back up, and then we just did a ground here. Because where does pin 5 go? Pin 5 goes here. So if we're just tying this straight to ground, then VCC is just going to flow through here. This is going to be at 0 volts. So then this is always going to be high. So this is always going to be low. The flip-flop is always going to be low. So, but however, if we move this, then we do a capacitor, and then he said 0.1 microfarad. Oops. Oh, you can't. Okay. Let's do this. .1. Okay, so this isn't going to change anything in here, but it is just sort of our like. And you know what, dude? Okay, not that anyone cares, but I'll glaze. I mean, like, bro, it's just text. It's just a graph. It's just like a labeled. It's like an edge and vertex labeled graph with slightly more semantics, but it's just a beautiful thing. Okay. So so that's pin 5. Wait. Why is it like this? That's so confusing. All right, so we have to do like A, And we have to do like a capacitor, right? Isn't there, I don't remember how this works, but isn't there like a, so there's that, but isn't there also the one with the curve? It doesn't have a footprint, right? But what if I search up, for instance, C0603? Okay, so you can't. It doesn't search the footprints, for instance. But now I guess I should just do like a little ask of if I'm looking Ben Eater's clock, a stable part of his clock module. He uses a 1U electrolytic capacitor. These are the black looking ones, right? And they're polarized. I'm wondering, since I'm trying to make a PCB with as much SMT as possible, if I could, what I should do. What should I do? I guess I should say I'm using logic voltage, so 5 volts and ground. Okay, SMD aluminum. So all electrolytics are polarized, right? Okay, so in my schematic, what do people typically use in KiCad for this type of part? The generic C, though, you pick the polarized capacitor symbol, because there's polarized, which is a plus and a minus. I feel like there's just a lot of choices, you know? Oh, weird. Okay, so then that's what we want, right? So, electrolytic, polarized, SMD. So now that's where this gets interesting, right? Okay, so let's do this. Now, the plus side should go here. And then like this. But I don't think that you typically do. I don't think you're supposed to do it like this. I think you're supposed to do it like. I don't know how people typically do this, but okay, cool. So, oh wait, but I forgot to assign this thing. So here's the footprint chooser. So I think, oh, see, hold on. All right, if I search this up, what do I get? That's not even a thing. Capacitor SMD. Aluminum electrolytic. So that's right. O603. So like, okay, but wait, what is O201? What is that? So this first one's the size, but then the second one is, oh, okay. Can I get one MFD in 0603? Or is it just too small? Like, what happens if I just look up 1 microfarad capacitor? Can I do that? Okay, so that does look like a 0603. Bro, that's the craziest thing. I don't know why LCSC doesn't allow you to search by value. Everywhere else in the world freaking lets you search by value. Okay, aluminum. I don't want cans. I don't want leaded. I want this. Okay, wait. Here, we should probably get a. Okay, nice. This is what I was looking for. So the only thing we care about is this. Wait, why is this 100 microfarads though? I don't understand that. Oh, do I have to apply it? But so, tolerance, voltage rating, ripple current. I don't know all of these parameters honestly, but so it seems like you can only get cans like this. I kind of needed just a breakdown of like. So this is the... So these are the, like... So wait, hold on. I think... Alright, so we have this. We don't want the package quite yet, but we want to see picofarad. Does it have package in here? So this is 0805. I think it'd be fine, right? I don't think that there would be really a problem with using... Okay, so the ceramic... Yeah, so these are the two main ones. So MLCC. So I think I should be able to go and use this. I wonder, can you search by tolerance? Like how much more expensive does it get if you does it get if you have a low? It's actually not that much more expensive. So presumably we could do this. Okay, so I don't even think I want to add a polarized thing. I think the MLCC is unpolarized. So let's just do that. Because it seems like the polarized ones are big. And the whole point of this is to build something that uses small surface mount components so that I can use the microscope and everything. So we're just going to do the standard capacitor. Okay, then here, this is going to be... So I hate this. I really... I feel like... Yeah, I feel like this whole thing is so insane. Okay, so here, which is the package we want in 0603? So if I just look up 0603, does that come with... Does that... 0603 metric? Yeah, that looks right. Wait, what the hell is going on? Yeah, so we're always working in metric. So let's just do this. Okay. See this? I hate that stuff, dude. The value feel... I don't know. It just... The whole thing feels like really kind of hacked together, I guess. That's why when we get to this in like an hour or so, I don't know how long it's going to take. it's like it's going to be so much clearer when you just have code and it just says, okay, here's the value. And I like that there's tolerances on this. But man, the amount of expertise and skill in designing PCBs, it's clearly a very high skill thing. All right, so but can we just write one U and that's like that? I don't know. What's this little plus? Oh, okay. All right. So now oh, but this is actually not that. This is a 0.1. So this is 100 nanofarads. Because this is the control voltage that's, and then can we go back actually to the circuit here? So the whole idea, we can stop this. So the whole idea, oh, this isn't in our circuit yet, but so this is the last design. This is a good picture actually. So we have pin 4 is tied high, and that's because there's an internal NOT gate in here that inverts it. But for some reason, that doesn't override the comparator's output. So if the reset goes high, I don't have the schematic. If the reset goes, well, so, oh, that's actually interesting. Okay, so they don't actually show. Oh, so this is a resettable flip-flop. So it's actually not like he said. It's a little different. I need to go get my book if I want to understand that. Because it's a flip-flop. It's not just an SR latch, I guess. So what do we need to do? We need to tie reset high. Okay, so let's copy this. Tie this high. All right, so we're getting there, kind of, right? Okay, let me draw the circuit. So now we want a 5 volts. And then we're just going to add a resistor. And I think I should just be able to look up R. Good. All right, let's keep this open. Let's close this because I feel like I learned what I need. We're going to be using... I wish someone would overlay... You know, should we read this? This is so cool, dude. Dude, I love these pictures of the die. It's just so funny how little I understand about this thing. I feel like at some point we should... It would be fun to do a 555 thing in Verilog and then use Magic and just design an IC. That sounds really fun. Okay, let's stay focused on the task at hand here. So we'll close the CAD later. I am planning to try to design something real like this in Zoo, because the whole plan for this project was to use as much code-based design as possible, but I am doing it the old way just because I'm more comfortable with it, and then once I'm like comfortable with the circuits themselves and the dimensions of the CAD, we'll just move on to Zoo and Atopile. Okay, great. So we have pin 5 is a pin. Okay, so pin 5. Let's do pin 5 now. So we're going to add another capacitor. If I copy this, okay, cool. So it does, so this is a globally unique ID. And that's good. So pin, oh wait, we did pin 5. All right, we can close this for now. Oh, I guess we didn't do this capacitor, and then we didn't do pin 2. So let's go back to here. Okay, so let's do this. So we have this thing, which is a 1 microfarad. And it's going to be tied, this thing is like this. But like I know that people don't do this. Like this is crazy talk. Like who in the world would do this? But I'm not experienced enough to know what the hell is correct. Okay, but then let's just ground it. So now what we're going to do is we're going to do and this is where things are going to get tricky because we want let's see, we don't want it to be okay, if this was 0 for instance, what would go wrong? I don't think really anything would go wrong. Cuz like there's not that much charge in this thing. Well, let's just watch the video where he adds it. Right?
If the positive input is below the negative input, then the curve switches off, and the output here is 0 volts. So let's think about what happens when we turn this thing on. Get this out of the way here for a second. So what happens means we're not going to be inadvertently resetting this if there's just some noise. So that's just something else we'll do. And then the last thing I want to do is I want to be able to control the speed of this thing. So we have it blinking at this 3.8 times per second or whatever it is, which is great. But it would be nice to be able to control it. And of course, you can change out the capacitor, change out these resistors, and hopefully you can kind of see how to do that. But what would be really nice is to add change this 100k resistor to a variable resistor. And so I have this 1 mega ohm variable resistor, and you just turn this and get a different resistance, and it goes from 0 ohms, so just a short, all the way through 1 mega ohm, which is 10 times more than this. And so what we can do is we can add this to the circuit here, and what we can do is we can hook that up in place of this 100k resistor. So if I take the 100k resistor out, and what I'll do is just hook up some jumper wires from pins 6 and 7, right? I want to connect between pins 6 and 7, and I'm just sticking it over here with the jumper wires because this is too big to just jam right in there like the little resistor was. But the other thing I'll do is I'll put it, instead of just hooking this variable resistor between pins 6 and 7 by itself, because when you turn it down, it goes down to 0 volts. That would be a direct short between 6 and 7, which would mean that when our clock turns off, the capacitor, instead of discharging like this, the capacitor will discharge almost instantly through here if there's no resistor there at all. And so then basically this would never go low, because as soon as this goes low, it would almost instantly go high again. So we don't really want that. So what we can do is we can put another resistor in series with a variable resistor, and that'll essentially act as a minimum value. So I'm going to put in this 1k resistor between the other.
So let's put bro. That's the thing about this kite. You look up potentiometer and it's like, all right, let's give you this 20 pin random IC that you've never heard of. There we go. Okay, so this is going to be hooked up to So it goes pin 6. All right, so let's say this is pin 6, right? And then we're gonna duplicate this. And then we're gonna wire this to here. Wait. That's not right. Okay, so we have a 1K resistor. This 1K goes to pin 7. But pin 7 Okay, I think I get it. So alright, so let's put okay, yeah, so this is gonna go to here. And this is gonna go to there. Okay, I think this is right. So we have the 1K that goes to pin 7, which is the discharge. But then it also goes through this potentiometer. Okay, so the only thing that we're missing here is the second resistor. So this just needs to be like this. So then we can rename this value to be 1K, 1K, 1M. And then is it a Q? Yeah, it's a Q. I think Q goes here. And then I guess he does this thing where he just adds us. Can we go back to that?
Timer that we're not using, and it recommends putting a 0.01 microfarad capacitor from pin 5 to ground to reduce noise. So what is it talking about? Well, we see on the scope here, we see this nice transition from 0 volts to 5 volts, but if we zoom in on that, or zoom in, what you see is that nice transition from 0 volts to 5 volts is maybe not so nice. There's a lot of junk in there. So if we add this capacitor that they're recommending from ground to pin 5, boom, clears it right up. So definitely recommend that, 0.01 microfarad capacitor going from pin 5 to ground. There's still some other noise if we go in even further, go into, going the wrong way, go all the way into nanosecond range. You see there's some overshooting here. And what's happening is when the output wants to turn on, there's a bunch of transistors in here switching and doing whatever they do. And when they switch, there's a different current requirement. So they're pulling more current, or they want to pull more current from the power supply. And they're not able to pull that current as quickly as they would like to. And then at this point, they end up getting more current than they wanted, and it kind of overshoots. And I'm surprised we don't see more sort of back and forth oscillations here. That's fairly typical, but it looks like it levels out pretty quickly here. But we're overshooting above, right here, this is 5 volts. We're going up over 6 volts, which may not be good. If our output is supposed to go between 0 and 5 volts, and we're feeding into something that's expecting 5 volts, and we give it 6 volts, that could be a problem. And the reason that this is happening is, our power supply is over here, and we've got all this wire that's connecting it to the board. And you say, well, the wire is just it's a conductor, just electrons flow right through, no problem. Well, almost. In a perfect world, sure, that's how wire would work, but we're not in a perfect world. And so this wire has some impedance. It's actually acting as an inductor. So when you run current through the wire, you get a magnetic field that builds up around it, and that magnetic field is going to resist changes to the current that flows through that wire. And so when we try to pull more current and hooked up, there's still doesn't, takes a little bit quickly. And that's just because we don't have all the impedance in this wire. Board, perfect here. Or cable like this, we want to. So let's plug this back in and see what else we can do. Put a capacitor just across our power connection here. That capacitor can sort of get charged, and then when this chip wants to pull more current, it can pull it from the capacitor. So we just take this is a 0.1 microfarad capacitor and just stick it right across those power pins. Boom, we get.
Yeah, that's great. Honestly, that curve is very bizarre to me. But, and what did he do? He put one what?
And just stick it can pull it from the capacitor. So we just, and then when this chip wants to pull more current, it can pull it from the capacitor. So we just take this is a 0.1 microfarad capacitor and just.
Cool. Oops. So I think that is the whole circuit, right? What is pin 3? Pin 3 is our output, actually, right? So we want to deliver that. I mean, so we want it. We want it to go through an LED, but then we also want to use it for something. Okay, so what did he say? 220. All right, so let's just take a wire here. What the hell? Okay, let's duplicate this thing. Make it 220. And we're going to make this go to ground. And then what we want to do is we want cool. Use net labels. Wait, what? Hide the VCC ground pins? Wait, why? So you're not double wiring them? That's confusing. Okay, let's just go through this. This does not help me at all. Okay, but what the hell? Global labels. Place net labels. Okay, L. I feel like that's wrong. But see, that's the thing. Is like this video doesn't even. Oh, wait, hold on. What about this one? Still, it's like, you know, that doesn't look right. What is that?
It's not for lunch, it's a treat.
Whoa. Where did you get this?
Whole Foods, they make something called a berry chantilly cake. This is, they put it the same. Oh, sorry. But I'll bring a knife and you can.
Okay. Yeah, I feel like none of these videos are.
of a custom PCB using
5 hour.
the LiPo charger components will be. Here is the regulator. Move that up a little. And I also have the battery connector, so I'm going to SDA1 and R7 will go to SDA2. So these indicate that the battery is either charging or it is ESS, and the out 4. I know that I need to got the second sheet.
I'm not seeing a lot of these. I guess that's a net label then. That's a net label. It seems like they use this ground and 5 volts thing pretty regularly though. So it's not like I'm... Okay, he's got the don't connect. Okay, so here's what he's talking about. So like you add these net labels. All right, but let's just move on. So okay, cool. So yeah, so we're gonna do that. So there, okay. Then this resistor, and this resistor. We want them all to be 0603. Okay, my thing is like hand solder. I don't know what any of that means. I think that's what I want. Just the standard. What are these? Are these probably these hand solder ones are probably slightly bigger, right? Yeah. That's interesting, actually. Elongated pad for hand soldering. I mean, we could do that. I don't think it would be a problem. I don't really want to do it, though. I kind of want, like, what you would actually use, which is 0603 metric. Okay. So that one. This one, I want to use the same thing. Bro, I really... It's just so annoying. Okay, let's see if I can get faster at this thing. I go to footprint, and then I search up... Okay, see, it's not even... I don't know. This thing is just really not that good. Okay. But we did it. We had all of these. Now, the only thing about this is, like... Well, actually, let me go look at what potentiometers I actually have. Because if I already have the part, then... Okay, so let me just go get the potentiometers. Because I think that they're the ones where they're like... What? C polarized knob? That doesn't even make sense. Okay, so we're gonna look at for this. I thought there was a way to also see the 3D model in this whole thing. What did they say? Alps? Why does the search not work, dude? It's so insane to me that... Great. Okay, that does look like what they used, though. So, but then, basically what that means, though, is that... Length of the shaft. These are all... What's the difference between these? I don't even know what the difference between these is. Detent? What does detent mean? Ooh, that's actually sick. I didn't know that you could do that. Wait, what? This is a 14? Ah, God. It's not right. No, look at that looks like a 555. Okay, I'm not exactly sure what that is. This is an envelope generator, so it's a totally different thing. Okay, cool. So we need to figure out what that is too. Just a basic 16-pin power connector. Okay, the op amp. Is that what mine looks like? Yeah, I guess it is. Where is what I'm looking for, though? Oh, see, that's nice. But then where's trigger? That's what I don't understand, though. Oh, trigger goes to... Oh, that's cool, actually. I kind of like that. But that looks different than the labels that I saw. That looks like a different type of label in general. That looks like this thing. It looks different than that, too. I don't even know what that is. I guess it is that, because the only other one is this. I don't know. But we're looking for... Oh, well, this doesn't have a knob, does it? Oh, it does. Oh, wait, it's all those potentiometers. What am I talking about? $9mm vertical PCB mounting potentiometer. Okay. Alright, but he seems to be using RD901F. This is actually a good resource. It's like a simple module. It's like pretty similar to my own. Okay, so let me just look and see if we try to assign this. Okay, there we go. So if I do... Oh, yeah, that's not what I wanted. See, why is that? Oh, no, the 9 is the height? Okay, fine. What's the difference here? Circular hole. Alright, let's just do this. And then I believe this should already have a footprint. Nice. So that's that. So I think the only thing that's not here is we want, there we go. So, I feel like I want that. But you know what? I want to, they don't even say, is this an LED? I love when you get to a link at like something like this and it's like, it's not even clear. I guess it's because this footprint is just a footprint. That's all it is. It's not really a, if I look at this up, is this an LED? No, that's a resistor. That's weird. I don't think it's necessarily an error, though. Okay. So basically, we don't need to worry. So let's do this. Now, okay, wait, but I actually do want to go to LCSC again. Because do we have everything set? Okay, so we have this set. Oh, wait. We have this set. Oh, wait, isn't there like an editor? Hold on. Oh, yeah. See, this is nice, because then you can just go through and see. Everything has a footprint set. The symbol fields table. That's great. So I think we're ready to jump over to... Oh, there's also this tool. That tool is nice. Okay, wait, if we do this, and then I think I have to draw like a rectangle or something, right? I forget what I have to do. Is it this? I don't think it's that. I forget what it is. How do you draw the board outline? Is it this? I forget what it is. We need to figure it out, but I want to go to the... I think it's Alt 3. Okay, so this didn't have a 3D model. The LED and the resistors and all of this stuff had 3D models. It's kind of annoying that this doesn't have a step file, though. You know, the cool thing is we could literally just design it. Because surely, if we go to here, here, and we look up this thing, we probably just want to look up this. That seems right. So surely there's a mechanical... Oh, there you go. So we could just CAD this ourselves. The only worry is, like, is this even accurate? Is this even what I'm buying? 901F40 15. What does that mean? That's pretty cool, actually. What are the 5 pins, though? I don't really get what the... Mauser actually has some pretty cool stuff, actually. It's kind of nice. I think I'm gonna make some food. Where's the 3D model? Okay, so I think probably what we'll do is we'll finish this clock module we'll build an enclosure for it, and we'll sort of not think too much about Eurorack, because the thing about Eurorack, I just feel like I'm not ready. Like, I want something that I'm confident is going to work, that doesn't have a lot of complexity to it. And I feel like the Eurorack, you got to do the connectors, you got to do these potentiometers. I don't know, we could probably figure it out. But the first thing is, I just want to, now that we have the A-stable, I want the monostable, and then I want the selector. And then we're going to build the enclosure, and we'll have something. All right, I'll be back. Okay. Man, I haven't streamed in so long, you know, just like fun stuff that I was inside and I was just like, oh, I forgot. I'm actually streaming. I'm actually getting to do the fun stuff, man. I'm actually getting to have a blast building something cool. All right. So surely connectors. It's probably not in connectors. It's probably in resistors. No. Oh yeah, resistors, potentiometers. Okay, now these are all of the packages they know about, right? But that's not even like, oh, alpha. So alpha, wait, is alpha the one that I want though? Yeah. So alpha makes this RD through hole, yeah. Wait, there's only one alpha through hole. Let's see, that can't be right. That doesn't even make sense. Okay, let's just try to look up RD901. This is the thing about getting electronics, man. Just like finding the parts is so hard. Oh, see, that's cool. Someone actually already did it. Okay. All right, so Alps. All right, so let's go back to potentiometers. Alps, Alpine. All right, wait, but let's just look for this thing. RK. Oh, there you go. Yeah, there you go. This looks like a side. Oh. No, so we want. Okay, all these numbers mean something. That looks good. There are other pictures of it? Yeah, that looks good. Yeah. I mean, that's fine. Um, did we ever find out what detent means? Oh, we don't want a detent. Oh, the dual unit? Oh, okay. Yeah. Okay. How does 66... Okay, yeah. So when they say 9 millimeters, though, oh, the threaded bushing. Oh. Oh. Wait, actually, hold on. That would seem to confirm a lot of confusion. Because let's go back to this. What was it called? So we don't want the alpha. We want the Alps O RK09. I think it is RK09. Yeah. So there's the K and then the L. The L is a double vertical. The K is a single vertical. No, wait, what? Let's fuck. They're just reselling these, man. I guess that makes sense. I don't really get what the 3 pins are. The question is, so we're sort of working in 2 dimensions because we're working to understand the common practice of Euro rack design, stuff like this. But then we're also looking to just build the clock module. And the clock module the clock module I guess what I'm trying to say is the LED is wrong. Because this LED is going to be shining in a dark case, which is totally pointless. So Okay. Okay, I'm gonna go on a walk. Let's see. I think I should take a step back and oh, that's actually not a bad idea. Making it a breadboard hat. I feel like I want to just build a small box. What is a Hammond box? Right, power. I didn't think about power. Okay. Barrel. So let's look at barrel jack. If I just search barrel, all right, let's ignore the LED thing for right now. Okay, barrel jack with mounting pin. I don't know what that means. Barrel jack with internal switch. Barrel jack DC. All right, let's do barrel jack. Okay, so surface mount barrel jack. I wish I could. Oh, here we go. Show 3D viewer in own window. There we go. That's what I'm looking for, baby. That's through hole. Yeah, I want to build a box because I want to know, like, how to build a freaking box, you know? Like, okay, so I don't know about all of this because also, like, we need to find this on LCSC. So it's okay. Did we picked that one, right? RK. We picked something. Yeah, we did. Yeah, we did. But I'm thinking we are gonna want to. Okay, so we have this thing, but now we want to go to catalog, connectors, banana connectors, audio connectors, automobile connectors, blade terminal connectors, board to board, and what is that? Oh yeah. Okay. I think it's DC power connectors. Connectors are the way of the world, bro. You gotta know your connectors. If you don't know your connectors, brother, you are in for a bad time. Yes, you are. You are in for a bad time. Alright, so it's clearly DC power connectors. Alright. Now, but sort by default, sort by most popular. What is the most popular? Lightning? Oh, that's just the sale. Okay, these connectors are 10 cents. So, but we want to know, right? Like, this is through hole. Okay, so this is what we want for real. Three amps, 30 volts. That's plenty. All right, that's good. So wait, let me go back to here. Bro, what the fuck? Why would they even put that in? That's not cute, bro. That's lame. Okay, so wait, actually this isn't what I want though. I want to I just need somewhere to. Okay, so that's okay. The standard potentiometer package used is the RK09. What is Alps Alpine? Okay. This is this and audio jacks have a sleeve to with a threaded nut that removes the need for explicit standoffs when connecting a front panel to the PCB. We do need to figure out their height. Okay, jeez, Louise. Okay, so we found that. Now, the plan is to use a barrel jack for the power. This is the most popular on LCSC under DC power connectors. I guess we'll need the male version of it, right? So we'll need to find the male side. Find the male side of the barrel jack to get cables for it. I don't know. It's probably super common. Why would it be the most common if it wasn't like available? DC 05. I don't know. Yeah. Okay. So that sounds good. So okay. Copy link. I want this footprint in KiCad. Is there already a footprint in KiCad that matches this part? Maybe just the most common on LCSC is not the because let's go to the second most common. This is the same exact one. This one, however, is another 2mm 6.4. Everyone loves these two. 2 5.6. I feel like that's kind of the one. Yeah, but that looks bad. I like this shape. I like that. So I wonder, actually, if I click on it, do I get, will it give me a, it's only an easy EDA. That's the freaking annoying ass part of that. That's why easy EDA is so much better. I wish I could just give it a part and it would do it. I am not doing footprint editing. Footprint editing is super annoying. That's not even... Bro, come on. Let's see if I put an LCSC part number. I doubt that this works. Yeah. Do they always have 4 pads like that? Wait, this is also not the right one, right? I don't think I want this one. I thought this is different, right? Yeah. This is the through hole one. I like this one. Bro, come on, man. Wait, you can reflow this? Dude, these drawings are terrible. This drawing is actually terrible. Okay, this is the front view. And this is the right view. Right? Or is this the left view? I can't even tell. The top. This is the right view. What happens if we look up... Okay, wait. So let's just try to go the other way. Let's look up instead... See, this generic, you kind of, this is the whole thing about EDA. It's like you kind of don't want the generic parts. Whoa. Why does that one look so massive? Okay, so like, for instance, this one. Okay, wait, what if we just go to LCSC? We go back to here. We search the okay, for I guess the better question is, what does that mean? Okay, so I literally do want to just make it the same. That's good with me. So we want the inside to be 2.05, which of course doesn't exist. That looks pretty good. But the issue also is that this is not guaranteed to be the same. Well, that's nice. At least we can get this part. But if, for instance, if I go on Amazon and just look at barrel jack, was there a 2.1? I just feel like this eats up so much time, but because there's kind of like, okay, so whatever, we know that. So wait, let's. Was this the one? I think this is the one, right? No, that's not the right one. Oh wait, let's actually do. Oh, that's actually cool. That's new. Okay, so I think that then we'll just go with this one. And then what did it say that the pins are? It said this is the sleeve and this is the... Pin 1, the center... Oh no, pin 2 is the sleeve. Pin 1 is this thing, and this is like this. Okay, cool. So now that we have power... Okay, now... Okay, I got it. Now I need to... Alright, because if we're just gonna... Bro, what? What the hell? Wait, what? Wait, what? I just want to use TL draw, bro. Okay, like this is what I'm thinking. Like we have this box here. There's gonna be the barrel jack here. The LED like here. And then the clock out. Right? Oh, and then we also need the step button. Step. So that's kind of the 4 things we need, right? Oh, wait, that's not it, though. Pot. And then step. So now we gotta go down a rabbit hole of learning about... So the idea is that so this is the front. This is F, front plane. And then this whole thing the PCB I guess is gonna sit like this, right? Snap fit sounds kind of fun. I've never done a snap fit thing. Wait, what is clock? Am I dumb? I like that. That's nice. Oh, but we need the mode toggle, right? Don't we need the mode toggle too? Whoa. Okay, so let's say this was the PCB, right? Then the box. Dude, I don't know how people do this. This is like, it's like hard. Alright, so let's say that there's 5 millimeters of clearance. Right? Well, actually, there shouldn't be 5 because there needs to be 5 plus 2 wall. So if we define wall as like 3 millimeters. Oh, shit. Okay, so if we did this, and we went back to the sketch, and we said that this is plus 2 times wall, plus 2 times wall. So if we have this, and we decide to, let's say that we say everything's M3, right? So let's just there's got to be a fast way to do this. Let's see if we can do this. Okay. From your lower left, okay. Alright, so let's delete this. Alright, so we're gonna do a Shift S here. We're gonna distance this. We're gonna say that alright, let's do 5.5. I was thinking 5.5 because the fiberglass is pretty strong, honestly. It's not like I'm going to be cranking down on it. Okay, so let's go back to this thing. We want to, what the hell? I think this is the worst way to do this. I don't think that's a good way to do it. I think what you're supposed to do is you're supposed to go circle, then mirror, then circle, or then mirror, mirror. I think that's the best way to do it. Oh, I don't have all my shortcuts, my standard library. Okay, so this is the board, right? No, this is the PCB. Am I still in this fucking sketch? That's not real, is it? Wait, that's not real. Oh, because it's got all this... Dude, hole is so dumb. Hole is so dumb. It's just got too much fancy stuff in it, you know? I just wish there was a fast way to select hole faces. Oh yeah, that's what you're supposed to do. Oh shit. Wait, I think what you're supposed to do is you're supposed to go like this, and then you're supposed to select... No. There's a way to select faces. I'm gonna try to find this video where this guy was just freaking flying. Oh, I think it was... No, it wasn't... Was it this? I swear there's a way to, like... Let's see, was it this?
In manufacturing, drill is to
No,
explore.
this is all cam stuff.
Create Selection enables you to select multiple faces or edges based on a rule in a single click in ePart Studio. Let's start with the face options. To access the Create Selection tool, click the mouse icon built into some features dialog options, or you can right-click in the graphics area and choose Create Selection. Select the rule option from the pull-down and click one face. Based on the rule chosen, Onshape selects all the other faces. Then simply click Add Selection. This will add the selections to an open dialog or pre-select the faces for the next feature. The Create Selection tool is additive, so you can use the dialog multiple times with different rule options to select all the needed geometry. Let's look at each rule option in the pull-down. The protrusion option selects all faces connected to the selection by a convex edge. Notice when I select the outside face of the handle, the indented faces are not selected.
There's got to be a way to do this, bro. I just know it in my heart. But I don't want the edges. I want to select the faces. Drag a box around the 4 circles. Right to left. Okay. Shit, so stupid. Okay, if I do this... Wait, but what if I do this? Control A doesn't work. Ugh, that's terrible, man. There has to be a way, too.
Hello everyone, this is Sufyan with a new tech tip on how to use window selection to be more productive in Onshape. In this example, I want to add fillets to all edges at the bottom of these grooves. You can individually select each edge, which can take forever, or you can take advantage of Onshape's Create Selection tool. But this approach would require time and patience because there is no option to select all edges at once. However, there is an effective way that does what you would expect using window selection. In a Path Studio, open the fillet dialog, then change the view to the corresponding side from where you can grab all the edges you want to select. Then click and drag from right to left. The selection window will appear in yellow and will capture all entities that have any overlap with the selection box. Depending on the direction in which you drag your mouse, the scope of entities that will be selected will behave differently. Let's do that again with another example. Using the same approach, you can select all entities in seconds to dramatically increase your productivity. Another example of working with the Use Sketch tool. In this example, I am trying to project all entities belonging to a face onto the sketch plane. Usually you need to select all internal entities like circles individually. But using the window selection technique, you can select all entities both external and internal at once.
That's kind of crazy, dude. That's wild. But I'm trying to select all the faces, dude. Okay, what if I try to do this thing? Wait, which side is it actually on? It's on this side. So if I go normal, and I zoom in, and then I select. Give me a break, dude. Why are they lying to me? Oh, wait, you know what? I forgot to do this, selection. Create selection. I want faces. Select patterns. There has to be a better way. Well, that's nice, actually. So, yeah, I can just go this, and then extrude on this, remove, up to next. That's not so bad. Okay, so the first thing we're going to do is extrude this by wall, and then we're going to how do I want to do this? I want to do this like this. I want to do G here, wall, wall, wall. Then I want to take this thing, and I want to, sure, 25 seems good. Okay, now the idea here is that the length of this will be slightly more. But we need to actually figure out the geometry, right? We need to figure out, based on how big well, let's just try this. So we're gonna do the this thing. I swear this is so annoying. There's gotta be a better way to do this, man. Oh, wait, actually, wait, hold on. Let me undo this. Mirror. Okay, select the mirror line. This. Select entities to be mirrored. So now you gotta go like this, and then you gotta go like. Oh, it's because I don't know, man. I just feel like I'm going so slow. Oh, but these actually, this should be like, I don't remember, but it should be like 5 or. Oh, you know what, actually? Let's go back. Because I need to think ahead a little bit. So we want to do this. We have this. So this is going to be like 2. And then this is going to be like, yeah, like I think it was probably like 5.4. We could look if I wanted, but I don't think I need to. And then here, this is going to be 5. That's not going to be right. Can't select this edge. Where did my real pen go? This back wall is 78, right? No, this is 75. Because what I'm thinking of is doing 4 threaded inserts on little stands. Okay. Yeah, I gotta lock in, man. So actually, that's fine, right? That's not like, it's not crazy. Ooh. It's a little weird, but I feel like that's fine, actually. Okay, then we mirror. And can we actually do 2 mirror lines? Because that would be the coolest, is if I could just do 2 mirror lines. Oh, wait, restore. Or specifically 2 lines. Should we do this? Should I go down the rabbit hole again of trying to make a custom on-shape feature? I kind of hated this, but let's just see if... I thought I had agent, bro. Where's agent? Because I swear, it just bothers me so much, dude. That I have to sit around and, like, click all day. Let's see if this works. Okay. I forget how to do this. I think I have to go here. Create. Do I do it in here? I think I do it in here. Create Feature Studio. This is like brutally slow. So I should be able to test sketch normal R C 5. Actually, we don't even need this. Custom feature script. Oh wait, I need a name for it, right? Double mirror. Can't I see? Do I have to like publish it, right? Commit. But these are just warnings, or are they errors? I think I have to create a version. Let's figure this shit out. This is what I'm looking for. Okay. Oh. But it's not in the searches, I guess. Where is it? Oh, okay. I actually have confidence that I might be able to write this. There is a function called mirror. Did it read the standard library? I know I'm just prompting and it's embarrassing, but it's like I don't really like their Why does it keep doing this? ChatGPT is like, I've seen that a number of times now. Stop with the. I wonder if anyone else has seen this. It's like a very bizarre bug. They've updated the model and now it just like constantly puts these. That's really weird. Oh, you know what? That's actually funny. It's because this is how it parses this. That's funny. Yeah. Why is it still searching? Shut up. Fucking God. Do we really want to do this shit? Whatever. I don't care. Let's just get on with it, dude. This is ridiculous. Okay, fine. So in this sketch, oh brother. Okay, so instead of that, if I do this, and then copy and paste them, so that's nice, right? Because then I can, oops. Now I want to move them. Hello. Oh, I guess I can linear pattern, right? So this is center to center, so this needs to be 70. So then we need to go back to this sketch. Is it going to be annoying to get my screwdriver in there? Probably not. This isn't, you know, this is just me getting right back into CAD. It's not like it needs to be perfect. Okay, good. Good. So we have this thing. Now we want to, now I got to go in here and just be like clicking away. See, I want to just be able to select the faces. I know that there's like a select equal faces on shape. Wait. Okay, wait, we're done with this. Select, no. Select patterns. Oh, it just did it. I don't know what this pocket thing is, but it just did it. So that's cool. So we only really need to make it like 10 millimeters. Okay, then in the assembly, we can insert the box and then this thing. And then we should be able to mate this with this. We need to flip it around. Oops. Oh God. Man, getting back into this is crazy. It's actually, you forget how easy it is to make mistakes like this. I mean, that's not going to work. None of this is going to work. We're going to have to start over. How did we get this so wrong? Is this right? 70 by 70, right? Okay. And then 5, 5. But what we want is, we want a hole here and a hole here that's 70 millimeters apart. Okay, so wait, let's try this again. This isn't gonna work, but let's just try this again. So this sketch, instead of doing this, what is this? That's the pattern. Okay, what we want is, this is 70. Wait. That's not right. If we did this, no, it's a variable assembly. Oh, bro. That's funny. Okay. I'm always so silly. This needs to be 60. This needs to be 60. Now if we went and do the assembly, we'll see that it looks good. And same with that one. So we never actually had to increase it in the first place. The only thing is I'll probably move this back a little bit. But that's plenty of clearance. There's no worry with that. Man, it has been a long time since I did CAD. Cool. So we need to go, can we just delete this? This thing is so stupid. All right, great. So now, yeah, I'm wondering if this is going to be big enough, right? Because, like, man, there's a lot that goes into making this right. Because, okay, the potentiometer needs to go somewhere, and that takes up like 13 millimeters. And I mean, if we think about this, the through hole component can't go into this standoff. Alternatively, we could use real standoffs, you know, and that would save some room. Oh no. Okay, so this is kind of the rough idea, right? So now that we have the components, we need to draw the board outline, and I always forget how to do this. I wish they had a command palette. Every program that's this technical needs a command palette. Is it this? This is a keep out, right? Pencil and square. I think we do this. I select this and then I draw a rectangle. Okay, now if I save this, then I go to this. Okay, cool. So now if I were to move this, it gets bigger. Okay, good. But now I wish I could dimension this thing. That's the craziest part about this, is that you draw this rectangle and then it's got to be exactly, you got to do it like this. Actually, let's just, if I do this by size, 70, 70. Okay, good. So we're actually going to want to change this. Oh wait, that's just a resistor. This. And we want it to be RD. I think didn't we go against that? We want the Alps. We want the Alps RKO9. Yeah, this is what we want. So if we save this and then go back over to here, do update. I mean, is that thing really that big? That's insane. Okay, so it's gonna be like, the barrel jack is like right here, I guess. The thing is we need, okay, so first let's do the mounting holes, right? I think we put them in the schematic, right? But like, if we just want to mount, okay, let's see this. So I can do place, footprint. Oh, and I can just do this, right? So mounting hole. Wait, that's weird. M2, M2, M2.5, M3. Oh, that seems good. So if I do this, so for instance, oh yeah. I mean, does anyone else think this connector is like absurd, bro? Like, why is this so big? Like, putting this all on the thing is like... Okay, wait. First off, we got to get this right. So... Dude, I hate this thing. This is insane. If I grab this, it's smooth. What's my grid at? Oh wait, my grid is... Oh, you know, that's actually funny. Is everything is so metric dominant that that's actually really interesting. I didn't even think about that. So, maybe we should... but then you're like inherently tied to this metric thing. Or I mean this imperial thing. If I do shift N, does it... Okay, it increases. So let's just do 5.8. Okay, so then that means that we have to go back to CAD. Is everyone getting it? Is everyone fucking getting it, huh? Are you listening? Are you listening to me? This is all part of the plan. So wait, that means... No, that's fine. This is actually really easy fix. It just needs to be 5.08. 5.08. But the Imperial Bastards, bro. If it were up to me, man, I would make, I would not be doing these 0.1 inch freaking headers, dog. Dog diggity damn, bruh. Alright, so we got this. So now what is this? What the fuck is that? I don't know what that is. But, what is this? Okay, what is that? I don't know what that is. Then this, so this needs to be 5.08. And I think that that's it, actually. It's really just... No, but you know what? Okay, wait, hold on. Let's just do this really quickly. So, MH from edge is going to be a 5.08. Cool. Now... Let's just fix this to be MH. Did it... Dude, I hate that you have to confirm everything. Like, please, 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 let me enter in anything at all. So now, though, we need to make this thing. So we want to make it a derived quantity. So we have board len, and it's a square, so we'll just keep that in mind. 70. Okay, then we want to say between holes is going to be 70 minus 2 times board len minus 2 times MH from edge. Okay, good. So now we have this quantity. So now, when we go into here, this needs to be between holes. Okay, good. So now, when we go into the assembly... Everything should line up. I believe that it is, but I can't tell. That's a pretty minor feature. I mean, it's like a pretty minor change. Like, I don't really mind it. So, anyways, so we got this barrel jack here. Then this. You can't rotate this? Oh, there we go. So we want to actually do... Oh, wait, but can we fix this? Oh, shit. Okay, so that means that we need to make our board size a multiple of 5.08 because that's our grid. So if we did 70 divided by 5.08. All right, so let's make it 14. So let's make it 14 times 5.08. Okay, that's what we're doing. All right, so our board size is now in freaking Imperial again. Thanks, bastards. Wait, why is this still not on here? Bro, what the fuck? Okay, wait. So here's what we're gonna do. This is 0. This is 0. Okay, now we're on the... Wait, why is it over there? Start point. Okay, does it matter? It really doesn't matter. Okay, so now if we do this... Okay, good. So there's that. There's this. Wow, these are... You know what? You just gotta learn to love it. There's just like a bunch of weird, goofy problems that show up. You know, and that's interesting by itself. Because, like... I have a horizontal barrel jack on my PCB, and I'm wondering what the recommendations are on how to on how to place it at the edge of the PCB in a way that will work in the enclosure. Same for the horizontal pot and the LED that needs to be on the outside of the enclosure or visible from the outside. And you know, there's a lot of complexity here that you just don't think about, man. When you're lining up panel-mounted parts on a PCB so they poke through a 3D printed box, the key is to treat the board edge as your panel. Actually, wait, hold on. The key is to treat the board edge as your panel reference and build in the correct offsets and keepouts up front. I don't even know what that means. Grab the Jack's 2D drawing. Because wait, we have, when I do Alt-3, okay, good. So we're going to have this. So the idea is that don't we want this flat? We want this to be flush, right? So like that. Why is it still slightly off? I just don't get it. So this is the mounting hole, right? But we want to draw... Can I draw like a circle on the front mask? And I want it to be... How big is it? I want this to be... So basically the 9.4. I want this to be 9.4. Right. See that? You're not even going to be able to go in. This does not need to be that strong, though. So if we go back to this. Wait, not this. This. Oh, wait. Did I just fuck something up? I probably did. This is the first take. You got to remember that you're always going to do a second take. It's just never going to be the right thing on the first one. So, actually they just don't look that thick. I'm wondering if we have another way to fasten. But I'm determined, bruh. I'm ordering a PCB today. I'm ordering my first PCB today. It's gonna be a big deal for me, man. So, and actually, you know what we want? If we instead but in our extrusion, we want to do this and then select other. Oh, wait, no. And then select protrusion faces. Nope. Select. Create selection. Select patterns. There we go. All right. I really like this thing. Create selection is nice. Okay, now I'm just wondering so let's go to on shape and then go to params. What? Params. My little standard library. Tap hole. Oh yeah. I could tap it. Because right now, wait, hold on. If we just go back and undo all of this nonsense. This thing is 5.4 for no reason. What? But I feel like I need a bottoming tap. Because if instead, in this sketch, we made this 2.8, that looks way more reasonable. I would even, there should be a hotkey to do this. Select. Oh, wait. Oh, interesting. I need to be able to restrict it just to that face. Select parallel edges. Nope. Select. Create selection. Edges. Parallel. Select patterns. Equal length. I just wish there was a Boolean operator. It's like, what is going on, dude? I know, I feel like I'm crazy. We don't need that. That's not relevant. It's premature optimization, bro. Okay, cool. Nice. So now instead of, okay, so we're gonna tap it and just see how it goes. Maybe I can print a little test piece. I guess we also gotta look out for this thing, because this wall could be annoying with a drill. I wish there was a way of just like duplicating this. Actually, can we duplicate this? I haven't printed on my Bamboo in so long, dude. Alright, so we're gonna take this. This initial sketch is just gonna be like 30 by 30. I wonder what the actual distance is, though. I believe this sketch here. 7.58. And then this sketch, I actually just want this. Okay, there we go. I'm gonna just print this part and see if I can tap it, because it's been so long. Oh, what? Lol. $12, $50, $1. File. Wait, I don't know what that means. What? Open. Downloads. That's not what I want. What the hell? Wait, there's auto orient, and then there's. Okay, cool. So now we can slice. We can print. Auto bed leveling, time lapse. Okay, cool. We'll see. This filament might be bad. I don't know. It's supposed to stay good in that thing, right? I'm not sure, honestly. Okay. So let's get back to the. Oh wait, you know what? Okay, so now what I want to do actually is let's just put all of these parts. Do I want it like this though? Let me look at this thing and. Oh wait, we don't have a. There's no 3D model for this? I wish I could copy this. Thank God I can't copy that. We are going to need to verify that this thing. So this is that is the 90. So I think I'm actually supposed to. All right, so that looks pretty good. All right, now we can just throw this around. Bro, what is going on? So we're gonna want to replace, oops, we're gonna want to replace this thing. So if we look at LEDs, why does it never have the 3D? Is that what we want? That's fun. Stop fucking around. My gosh. So I think I think you're supposed to line up that part with the, so like let's do this. But we don't need it to be tall though. Right? That seems good. Let's do that. Am I allowed to do that? What does the green thing mean? Oh, because you can't have, oh, okay. That seems right. That seems pretty good. Okay, now where's my auto router? Multiple footprints of the reference designator ref star star. Go to, in PCB, wait, if I save it, wait. Tools. Wait, where's ref star star? Oh, 'cause this? Bro. Um... Oh, fuck. Wait, did it work? Wow, that was great. Cool. It needed vias, dude? Come on. A board this simple should not need vias. Look how many vias it needed. One, two, three. What is that? Why did it make that? What in the world, bro? What in the world? I just don't know what that was. So we have the potentiometer, we have the power cable. Okay, so we'll work on the layout more later. The thing that I'm wondering is, okay, so have the basic astable clock, but I think I want to output the clock signal instead of just having a LED, though I want that too. What should I do? I don't want headers. This is the like scope, right? Yeah, that's absurd. I'm not doing that. Still not doing that. Yeah, I think I'm gonna do I think I'm gonna do. I think I'm gonna do that, bruh. That seems pretty good. So what we're gonna do here is we're gonna add. So let's delete this crap. No, you have to do it. Yeah. Okay. So what we want is it should be in connectors, I'm guessing. And then I want like a TS. Jack. Cool. Okay, so the the sleeve is the ground. Okay, fine. So now let's go to LCSC. Oh yeah. Oh yeah, baby. That's the kind of shit I like. Look at that thing, man. That's SMT, bro. Oh no, that's through hole. But I wonder if they even have this stuff. This seems like fancy, newfangled stuff, bro. Find out if there's a way to find out if there's a way to, in the KiCad footprint viewer, there is a button that allows you to view the 3D model. And every time I open up the footprint viewer, it's unchecked, even though I left it checked the previous time. Is there a way to default it so it just always shows me it? Because I want to see it every single time. Oh, is that a real thing? Not even a thing. That's so stupid. Who the hell thinks that's a good idea? I want to see this thing every freaking time. Because I kind of only want to select the ones... Ooh, this one. Korean H-row parts. Does this thing have units? No. Like, alright, let's just do a little punchline thing. The thing that's sick about Atopile, and I mean, I could use Easy EDA, right? But I don't really like Easy EDA, honestly. But we could just do it, you know. Wow, these are oh no, they're 18 cents. I mean, the fact that something like that is 18 cents is actually crazy. But I'm wondering if... Well, this one's 11 cents. Gold. This is SMT, though. Gold! Alright, let's just do this. I don't really care. And we're going to copy this. And this is the cool thing. Is if I go into clock here and I do atto, or if I do add part, and I just put this in. Oh, so oh, interesting. Okay, wait. So let's try the next one then. I kind of want through hole though. Most of these are SMD. What's the default? Let's go by default. Wow, this one's 4 cents, dude. That's crazy. Yeah, we could try it. Why not? See, and now I can use it. But do they all look different? That's kind of my question. Oh, wait, I don't want to go to Shohan's page. I want to go to this. Or is it pretty standard? This looks like... Oh, it's not through hole? Oh, this is nice. Why is there 5 connectors though? I don't like that there's 5 connectors, because we might just have to do this in freaking easy EDA. Okay. It just doesn't... Well, I guess we have to just read the data sheet. All right, let's try to go... Did this one didn't have a thing, right? The through hole one didn't have one, right? No, wait, it does. What? Oh, bro, then why do they not design yet? Good. All right, let's just go back. Because I feel like SMD is going to be weird on this. Look at that. Zero in stock. That one looks pretty good. What's wrong with this one? Is it TRS? That's the crazy thing, is it looks like all of these are TRS. Yeah, this is a TRS connector. But I want a mono TS connector. I'm wondering if that's even possible. Because it seems like all of them are going to be... Because, like, we have 2 ears. Well, who cares? We could just make the other ones don't connect. All right, so well, the problem is this one. This is the through hole one that didn't have a part, right? I keep forgetting. Wait, this one's SMD. Is this the most popular? Just deciding on the parts is the hardest part. Wait, actually I wanted to look at this. The potentiometer, the LED. We're gonna need to do the switch and the button. Then we have the standoffs. And then we're gonna have a front case. And the front case is gonna be a curious thing to design. $293. Yeah, okay. But this one, okay, I keep forgetting because all of these parts, they're like the same to me. But this is like the uber Chinese one, right? That like I couldn't really. Oh wait, this is actually pretty good. Oh wow. Wow, look at these test results, dude. That's awesome, man. The only thing is that first of all, I don't know why there's 5 pins. Unfortunately, none of these really look right. I don't know why they're placed in such weird ways. So I'm wondering if we added... Did we add this one? Is this the one that we did? I think it is, right? No? The thing for me is I wonder how they're getting Shohan 327. This one. They have a step file, they have a symbol, and they have a mod. And a mod is a footprint, yeah. Okay, but I don't really get the pinouts. Let's quiz it. Okay, so just to like have something. Okay, let's see. Let's just see if this will work. We have these three things. Kipper Jamon. Wait, actually, you know what? I could probably just point it to that. Like, watch this. I could probably literally just do this. I'm gonna delete this thing. I'm gonna... But where is that? Let's just... Oh, but I can just make this directory. But actually, I'm curious if we go to user share KiCad. Okay, so there's symbols, footprints, and I wonder if I can just put them all in the same spot, right? So let's go to so if I go to source, Atto, nope, Eurorack, clock, parts, and then I get this and I copy it, and then I bring it back to source, KiCad, mylib, this. Is this gonna work or does it need to be flat? Let's just do this. Okay, so now if I do this, I just go all the way down and I say okay. Okay, so what was the pinouts again? Do I trust this? Honestly, the pin 1 is the clock out. Pin 2 is the ground. Okay, but then the problem with this is we need to go to manage symbol libraries. Is that a footprint? What is that? But where is that? That's not a thing. I almost guarantee that's not a thing. So how do I add my footprint library? Manage symbol libraries. Maybe it is a thing. It's still not found. So we need to select it though. That's our problem. We need to select it because this is namespace to the LCSC part number. But what we want is mylib. Why isn't page down work? But it doesn't have anything in it. Why doesn't it have anything in it? Okay, so let's try it again. There's no keep outs. You can just put this right on top of here. So how do I get the 3D model of this thing? Fuck yeah, dude. That's a sick step file. Wait, what's going on? Wait, why can't I fucking pan? Oh. What is this? This is the potentiometer? So I think, I mean, I feel like that works, right? That's a good workflow. So I'm wondering if just like every time well, okay, let's see if I can do KiCad easy EDA import. Maybe we can just do this. This is going to be importing into well, you know, we don't actually have to fix all that right now, because how much more do we need? Okay, so all we need now is the button, right? And actually what we want to do, we want to move this over here. Is that too close? What's the distance between here and here? Is there a way to measure? Oh. Isn't there a ruler thing or something? That is not very far. 1/4 of a millimeter? Ooh, I want to do this thing, by the way. I've always wanted to do this thing. I thought there was a thing. But I don't even know what this is doing. How do you add a ground? I don't know. Okay. So oh, fill style. Fill style. Why isn't it doing it? Oh, there you go. That's cool. Okay, cool. That's pretty interesting, actually. Oh, hey, my part is probably done. Let's see how it went. Yeah, the thread is pretty good. I would probably make it a little bit smaller, but it's good. All right, let's get rid of this god-awful nonsense. There we go. Okay. So we have the audio connector, we have the LED, we have this massive What are these? What is that? I guess it's a hole. Okay, great. So we have this thing. Now it's why is it red and blue? I don't really get that. Like, there's not going to be copper on the other side. Oh, wait, actually, you know what? There will be. Oh. No, that's fine. That's fine. Because the through holes are plated. Okay. All right, let's just get on with it then. So I think that this is the whole thing. We could just rerun this routing program. I don't know why it does this. Wait, but I wanted to view the settings, bro. Via cost 500, bro. Via cost 500. Wait, how do I remove all traces? In PCB News right-hand toolbar, the selection filters. Ooh, that's nice. Only tracks. I set the via cost to 500, bro. Hold on, it probably reset it. I don't know why this is so annoying, but it is. Okay, so every time you need to set this. So wait, why isn't it updated? Something weird happened. I think I'm gonna restart KiCad. We can close this. Okay. So wait, I wanted to do all, delete, save, route. Cancel, settings, auto router. Via costs 500. 550. Slow. Still did 1,000 vias. I thought it used to give stats on how many vias. Oh wow, this has this built in. Oh whoa, you can like shove them. That's weird. Save. Okay, so now actually, you know what? I kind of want to try this. Ooh, this is gonna be interesting. Yeah, all right. Okay, so I think I'm gonna end this stream. Wait, unrouted. Is that? Oh, you know what it is though. Wait, unrouted. That's not right. What does it mean unrouted? Let's try to route this thing for real. Because, like, just straight up, I already immediately see... Wait. Oh, wait. Oh, you know what happened, actually? I think it kept those vias. Can we try this one last time? You'll fall in love tomorrow. 550. Speed slow. I'm just guessing that speed slow means it runs a harder optimization. See, that's pretty good. That looks way better. 1, 2, 3. I don't know what unrouted means. Does anyone know what unrouted means? Because I feel like that's just including this shit. Oh wait, unrouted went to 0. I don't know, maybe it's just delayed. 9 vias. Okay, so the main thing now is this is in clock. Where is clock? What directory is clock in? Claude.md. Actually, I really like stuff like this. But also, if I'm making a Git repo, I don't want this nasty shit in there. We could, of course, just start over. And I'm actually kind of down for that. Okay, so what did we do? So how long have we been going here? Whoa, 6 hours? That can't be right. Wow, I didn't do anything for 6 hours? Damn. Alright. So we made this little box with this thing, with this a hack PCB thing on here. And then we kind of got this thing, which is nothing. All right, that's it.